Good morning, students. So in this video or in this class we are going to see about what is a switching surge and what are its effects. So it is the one of the internal causes of the over voltages in transmission line. Already we have seen in the previous video. So kindly go through this video. It is the switching, the reasons for formation of switching surges in transmission line. Thank you.
Today we will have a look into transmission line switching surges. I will work with the simulator below. There is a tutorial movie on this YouTube address here. The question is, what happens if you switch on a long transmission line? In order to get the answer, I have built a simple model. This is a source with a transient source impedance. Then I have a breaker which is open and then closes on a long line. And then I have a load impedance. So let's see what happens if I use such a model. So let's first build a model. So here is now my source, and I want to check if the source behaves the way I would like to have it. Remember that I can switch on and off the visibility of the values elements here. So I switch it off for the time being. And now I want to check if this source behaves the way it should. You see now this is the source value and this is the TRV. TRV, by the way, stands for transient recovery voltage. And I would like to have a kind of standard TRV, so I reduce the element here. I want to have an overshoot of 1.4 more or less. So this is what I would like to see on the source. And now I add additional elements. I add a breaker. And I add a long line. And I add a load resistance. With maybe also a capacitor, which is simulating all the bushings in the other end of the line. So I would like to see a line which has a damping of, let's say, 40 micro ohms per meter. And let's start with a 100 kilometer long line. Let's see what happens. So this is what I have here. I want to switch on my breaker so it starts open. And I want to switch it on after, let's say, 10 milliseconds. Could be any other value. And I want to see the voltage across the breaker. I want to have a load impedance which is very high right now. I just want to measure the voltage at the output of the line. I want to measure something. And I want to have a small capacitor of, let's say, 10 nanofarad to start with. So let's see how this looks like now. I want to run it for 20 milliseconds. Let's go to 40 and let's go to 1000 steps for these 40 milliseconds, and let's see what happens. So you can see now that the breaker closes here when the voltage collapses across the breaker, and you can now see at the end of the line you now have an overvoltage. The situation can even get worse if I have a pre-charged line, trapped voltage, and the same trapped voltage should be in a capacitor here. And then let's run it again now and let's see what happens. I have to have the breaker open when the whole thing starts, otherwise nothing will happen. So So you see, it's even worse now. One of the measures to reduce the overvoltages at the line end is to add a closing resistor. In series is a closing switch, and the closing switch closes a couple of milliseconds before the main breakers closes, and that reduces the overvoltage. Let's see how. Here you can see the effect of the closing resistor. Let's run it. So you can see that the overvoltage at the line end is much lower than before. And you can also play around with the value of the resistor. You can see the higher the value is, the higher the overvoltage you will get. And what you can also do, you can play with the closing times. The scheme with the closing resistor is relatively complex, and therefore it is preferred, if possible, to, instead of having a closing resistor, to just add an arrestor at the line end. Let's see how this works. I have now added a surge arrestor at the line end, and let's now set the parameters of the surge arrestors. You remember that the peak value of the nominal voltage was, in this case, 450 kilovolts. At the surge arrestor, I need to set the maximum continuous operating voltage. The nominal was 450, so for the maximum, let's assume now it is 500 kilovolts. Now I have 500 kilovolts, and I would like to have a protective level of, let's say, 1.5. The protection per maximum continuous operating voltage is here. So I reduce now this arrow here until I get around about 1.5. And then the settings should be okay. This one is just to check the impact of the voltage on the current through the arrestor. And let's leave the rest as it is now, and let's see the impact it has on the overvoltage. I also remove this trace here. So you see, the maximum overvoltage is now at less than before. Let's now compare the impact it has. I just add a switch to switch on and off this arrestor. So let's repeat. So this is now the overvoltage with arrestor, and now I take out the arrestor. You can see that the overvoltage is drastically reduced. So learning by doing is the best way to learn, to understand and to get expertise. So as usual, I recommend to use the simulator, build up the circuit yourself and play with the parameters.
So in this class we saw about the effect of switching surges, and in the next video or next class we will be seeing about what are the various temporary over voltages present in the power system. Thank you so much. Thank you.